Hello, can everybody hear me? Is this thing on? Never. All right. So I just want to preface this video with again what's exactly in the description. In no way am I endorsing modification of this game. I have two goals for this video. One of them is just an introduction to reverse engineering. It's cool, fun. Um, and it passes the time sometimes. My second goal for this is hopefully Kabam watches this and understands just how easily or how little their app is protected from being modified. And I was going through initially and unpacking everything. The average mobile application will take me, a few hours trying to get into. This took me about 10 minutes because of just how little security there is involved. Um, so to get started with, uh, if you're talking, we can't hear you. Hold on. Can you hear me now? Test, test. Can you hear me now? So you can hear me now, Berto? See the volume thing at the top? That's the one I have at max. Um, well, I use headphone mics. I use yeah, Soundcore Q35 headphones. Um, all right, well, I guess I'll go through this intro again. Since the entire time I was talking, I was on mute. Um, I want to preface this by starting out with in no way do I endorse modification of Marvel Contest Champions. This video is not intended to show people how to modify um, MCOC. It is intended to show people how to reverse engineer things just for the sake of educational tools, but not to modify the game. My second intention for this video um, is can't hear you still? What? Can you hear me now? Good, good. Oh my gosh. Um, Geez, like 4 minutes into the stream and I haven't nobody hear anything. All right, so let's start this intro for a third time. Um, so to preface this video, I am in no way endorsing the modification of Marvel Contest of Champions. I have this in the description, but this is educational only. One, to serve as people getting into reverse engineering, um, and two, to show to Kabam just how little security their application actually has and why modders in the game are so prevalent. Um, so I do this for a living. I modify or I reverse engineer applications and then provide security patches. That's what they call white hat hackers. Um, on average, to get in the average application might take a few hours, maybe a couple days. For MCOC, for being such a top selling application, it took me about 10 minutes. Um, for something that sells that well and has such a large model problem, there really needs to be more security than this. So I'm going to walk through exactly. So we're not going to go through the entire thing today because that would take a long time. But part one is going to consist of just unpacking the code, walking you through how you can look at method names, how you might be able to modify something. And then in the follow-up video, I'll show you how to repack it all back, how it becomes a modified file, and other exploits like that. So to start out with, we have to know, and most people do know this at this point. Let's get rid of this window. Um, Marvel Contest of Champions is built using Unity engine. So Unity is intended to be a cross-platform um, build system. So it builds for Android and for iOS. What's the system you use? I use Android. Um, so right now the screen that's up, I use a Windows computer and I use an Android phone. Um, so Unity is intended to build cross-platform, and it runs on what's called the mono-CCL. And so mono-CCL is just a version of .NET. .NET runs on every single Windows computer back to I can't remember what. Um, .NET is a framework that allows applications to run. So we can essentially treat this application as a .NET application. Now, uh, what's the problem with treating it as a .NET application is that .NET applications are easily viewable because of how they're compiled. They're compiled on what's called it's a virtual machine, and that has an intermediate assembly language. That assembly language is easily reconvertible back into code. The code is C# code. Bad question on my part. What do you use to see the code, like that thing you have up right now? We're going to get into that, Alberto. That is part of the stream. We're going to cover it all. It's going to be a long one. And you can ask questions also about anything that I'm saying because there's so much to cover. Like reverse engineering has to start at a basic level, but I'm kind of glossing over a lot of stuff because again, this is sort of a video for Kabam too, and they already know a lot of this. Um, okay, all right. So again, so the problem with .NET is that it's easily reversible. You can unpack it using tools. This one right here is called DNSpy. You just easily open up and you have the code right there in front of you. So like, let's see if I have a file so let's open a DLL somewhere. Do I have anything? No, this computer's pretty blank. I had to re-download a lot of stuff. Um, so anyway, part of the security measures that they'll do, and I think this is really the only, well, they have two security measures they implemented, but one of the things that they use, that Unity uses, is it's called IL to CPP, which stands for Intermediate Language to C++. C++ runs natively on hardware, while .NET, Mono, whatever you want to call it, runs on an intermediate virtual machine. So compiling it natively allows you to not view all these method names that are easily exploitable. So actually, if I open this up, I can just show you something real fast. So these are DLLs in the .NET system. So if I just wanted to browse through these things, so you see I can just easily look at these method names. So this is .NET. They had no intention of hiding these things, but this is how it would look if it was un, uh, an unencrypted dynamic library. That's what DLL stands for. So this is how everything would look. So you can easily read what the method names are. That usually means you can know what they do. So public can convert to string. That tells me that it's a method that says, is this an object that can convert to a string value? So I should not be able, in a properly obfuscated application, I should not be able to see that information. So let's get started, and I'll show you why this is so important. All right, so some of the tools that I use. In reverse engineering, you can do things the hard way or you can do things the easy way. The easy way is using tools that people have already put together. And in one of these cases, the National Security Agency put forth a disassembler called Ghidra. And this is a free software that you can find. I'll pull it up. Uh, Ghidra download. So they released this, I think it was last year, maybe 2 years ago. But the NSA, this is for security research purposes. And they offered it to the public as a free download. And this is just something that allows you to view native intermediate. Somebody say something? Hold on. Oh, sorry. This just allows you to view the assembly code. That doesn't mean that you're able to view method names and to, like understand exactly how everything works, but that gives you access directly to the code. So I'm gonna stop rambling. We're just gonna start doing this. The first thing that we need to understand. So we're gonna do this from an Android perspective, but this also applies to iOS. I don't have an iOS device, so I'm just gonna do this from Android. The first thing that we need to understand is we need to get the APK. So the APK is the file that you download from the Google Play Store. So when you install Marvel Contest of Champions, it installs an APK. So you can use online downloaders for this, or you can use an APK extractor based straight off your phone. It doesn't matter. I'm not going to re-download this because I already did this ahead of time, so we don't have to waste time doing downloads. So I'll show you here. I downloaded this from APK Pure. And so now here we have the Marvel Contest of Champions version 37 APK. Now, what do we know about APKs? APKs are essentially just zip files. That's all they are. If you didn't know this, now you know. You're not going to be able to extract this using the built-in extractor from Windows, but if you download 7-zip, which most people use 7-zip too, then all you have to do is go here, 7-zip, extract files, and it'll just extract these all to a folder. And these are all and you're just unpacking the application at this point. So this is what that gives you. Now that you've unpacked the application, this gives you some limited access to things that are going to lead us in the right direction. So we have these things called dex files. These are just Java classes. We don't really care about them too much because we know that this was built in Unity engine. That means limited Java code is going to be written. Oh, hey Snake, how you doing? Uh, this is how Blizz wins in BGs? Yeah, totally. This is totally what I use. Um, so what we care about is, as I was describing earlier, the IL2CPP symbolic object file. When Unity compiles down their application, it goes from uh, Unity or the uh, Unity application to the intermediate language on Mono, and then all the way finally down to C and C++ files, and that gets stored. So we go here to lib. That gets stored in both of these folders, and it's called libil2cpp. Lols. Sorry, I know this is a lot over people's head, but like I was telling Berto earlier, like I'm glossing over a lot of information that you may or may not know. We're gonna get to some of the more fun bits after I explain a little bit of this. This is just background info. So ARM64 V8A, this is just a 64-bit device, which is what my Android phone has. V7A is for a 32-bit device. We're going to be focusing on a 64-bit device, so we're going to come here. This is the important file in question right here, libil2cpp.so. This is what's going to contain almost the entirety of the game's logic code. So this is what we're going to be focusing on. Yeah, I'm trying to understand, but it's all going over my head because I'm dumb, but I support you. I'm sorry. It'll get it'll get a little bit more fun once we start poking around in the actual code. Um, so if we open this up, it's gonna be a lot of here. I'll just open up with Notepad. It's gonna be a lot of nonsense. There's a lot of nothing in here. Did we see here at the very beginning? So this is an ELF file. Now that's very important because portable executable files are how these run. Let's get rid of that because that's not part of what I was talking about. So we can open up this file in any disassembler. So like I was talking about earlier, you can use Ghidra. So I'm going to have a walkthrough here because I didn't open any Ghidra yet. Let me get to Ghidra first. So if you weren't here earlier, Ghidra is just a disassembler for looking at native code. Let's see, where'd you go, Ghidra? Here you are. Ghidra 10.2 public. And we're just going to run this Windows batch file, which is going to run the actual Ghidra disassembler. Again, this is completely free. I don't use this program because I have another program that does close to exactly the same thing called IDA. I think for ARM it's actually free, which is ARM is what runs on Android devices. It might not be. I mean, they support a lot of other processor types, which is a couple thousand per license. But I think for ARM it's actually free. But in any case, so we'll go here, File, New Project, Non-Shared, Project Name, we'll call it MCOC. So now we have an active project. We're going to come here. Oh, sorry, just kidding. We're going to add file, import file, and we're going to go and search for this libil2cpp.so file, which this is written in Java, and I hate the Java, the J-file importer. It's so freaking nasty. If I can find my freaking downloads, there they are. All right. So Marvel Contest Champions, open lib, ARM64, and then libcp. All right. So we're going to import that file. Now, Ghidra will automatically tell us that this is a ELF file, portable executable file. So it's automatically selected the architecture for us, so we don't have to worry about that. But if we wanted to go in and edit the architecture, we could. There's more supported architecture. I'll show only recommended language of Tyler specs. So if you unclick that, there's a lot of different supported architectures. But in this case, they hit it right in the nose. So it is ARM64. So it's going to load this file. And while it's decompiling, I'll show you the other version of this because this actually takes a decent amount of time because it's just a massive file. While it's loading. Hey, maybe it'll be faster than I thought. All right, never mind. We're going to do this the other way. Okay. All right, so it's loaded. Now we're going to analyze the file. Yep, go ahead and analyze it. We're going to stick with all the defaults. All right, so it's running analysis right now in the background. We're going to let that go. No, thank you. All right. So now, so we can speed things up a little bit. Let's just say for the sake of argument, we don't care about any of this back-end code. We just want to look at the method names, and that's all we care about. So when Unity compiles its application code down, it ends up saving, sorry, it ends up saving a lot of the object information in what's called a global metadata file. So if we go to, what was it? No, not com, just kidding. Assets, that was it. Assets, bin, data, managed, come on, managed, metadata, global metadata file. All right, Kabam, here's where you fucked up part one. This global metadata file is not obfuscated. So because this global metadata file, I'm also taking bets on how many times Blizz got laid. I'll take under 4. Oh, Jesus, Berto, come on, man. You have to go that far. Um, with this being an unencrypted file, and I'm not going to get into the reason why I know it's unencrypted, but it's unencrypted. I'm able to extract all of the object, the symbol headers, object information, and I'm able to use a tool called IL2CPP dumper that's going to generate a dummy file that lets me read all of the method names. So I went ahead, IL2CPP dumper right here. I'll search for it just so you have an example of how to do it. If you're watching this video back, IL2CPP dumper. If you go here, it's Perfare IL2CPP dumper. Tells you everything about how to do it, how to run it, and I went ahead and did this ahead of time, under 5. I'm not even going to respond to that. I'm not even going to respond to that. Yeah, I went ahead and did it ahead of time so we don't have to go through all this process. So in the IO2CPP dumper, we go to here, we go to bin, debug net46. So I came and I deposited this libio2cpp.so file right here. That works in conjunction with this global metadata.dat file. And when you run this program, it generates this dummy DLL. And this dummy DLL contains a lot of information. But the important bit is this first file right here called assembly C#. Because we just extracted all of those method names, we now have a worldview into exactly how Kabam's code works right here. So in order to open that, we take this dnspy. I should probably done that. Explain that too. dnspy. This just so you go here. It's also on GitHub. dnspy. It's free. Download it. Okay. So all we have to do here is go to File, Open. So let's find that dummy DLL, assembly C#. This is where a lot of the fun begins because now we got to see what Kabam is doing. Now, dnspy will start to load things as you're calling them. So here we already have a decent look into Kabam's code. They have a namespace called Battle.io. They have Relics 2, Move Editor. Some of these are auto-generated by Unity. Some of them are code that's generated automatically in the background. Some of them is generated by Kabam. But there's things that we can be fairly positive about. Like Relics 2, this namespace is not something Unity is going to ship out because that's not something every game has. So we know that Kabam generated this code. So we go to Relics 2, we can look at Curve, and there's going to be a lot of information here, but the most important bit is we have all of their names sitting in front of us. So let's say, for example, we wanted to do a player attribute modification, a damage attribute multiplier. So we're going to come here and we're just going to search for something. We're going to hit, search button. And we're just going to search for anything containing damage. Oh, look at that. We had a lot of results already. So yeah, we have a ton of results. It's still going. Let it go, let it go, let it go. All right. So we're just going to scroll through these. We have this one. It's called damage multiply. Let me search it in here. Nope, nope, nope. So this is Ida Pro that I was talking about earlier. Same thing as Ghidra, but a little bit different. I think Ghidra might be bogging down my RAM right now. So we're just searching for damage. So we have this battle damage manager. And if we look down here, we can also see other things like attribute set data crit damage. Then we have fight summary damage logger. So there's lots of different damage events that we could potentially go in and exploit. So let's say, let's go back to DN Spy and let's say, let's go search for crit damage. There's a lot less occurrences of crit damage. So player attributes, crit damage. That looks like something that we definitely want. So let's get this screen back down. So crit damage. All right, so as I was saying earlier, this doesn't give us any code in this view. This just gives us the name of the function or the field or method name. And then it gives us, here we have address. So the offset is the physical address and where it resides in memory. VA is the virtual address in which it resides in memory. And then this is the relative virtual address. I'm not going to go in and try to explain how all this works. When we're doing this from a disassembly standpoint, we care about the physical address, but if we're doing this dynamically, we care about the virtual address. So we're just going to take this address, and by address, it just means location in space. So this is where this resides at this address, crit damage. So we're going to go into our program here, go into our IDA view. We're going to jump to that address. Yeah, my RAM is getting bogged down real hard. So I'm just trying to copy paste right now. Come on. I'm gonna shut Geeter down right now because it's taking up my resources. All right, now I can actually do stuff. So how much RAM do I have? Here at 32 gigabytes. I have 16. Keep in mind though, this is a really old computer that I built. I built this computer in like 2012. Still rocking DDR3. Like an i5. Like I really haven't had a need to upgrade it because I got stuff through work. So, all right. Can we please? Yes, thank you. Finally. All right. So we go to here. Oh yeah, by the way, I should explain something else too. That same program that allowed us to generate this dummy DLL also has these scripts for these disassemblers. So I ran idoinstruct py3 because I'm using Python 3 and I wanted structure information. What that does is it takes all those names that we just saw here in dnspy and it imports them to the actual code view in IDA. Because otherwise this would just say something like subfunction 2EEEDB8 or something like that. So now we're looking at a function, and this is the important bit that we actually care about. So get crit damage. If we go back to dnspy, we're going to see what this function contains. So it's just a getter, and it returns a float value, which is just a data type. So basically, when you call player attributes dot crit damage, you are getting the crit damage value from the player game object. So all we would have to do here, and this is, again, a very simplified way of looking at this, and there's lots more that you could do with this, is make this function return maximum value. So right now it returns the actual value of what the crit damage should be for a player. But if I wanted to return a static value, I can just come in here, remove all the instructions, and just output at the very end of the function. I don't know, what's the maximum crit damage value in MCSE? I don't remember off the top of my head. But whatever that maximum value is I come and I just deposit it here, repack the game, and I'm done. Suddenly I have every single champion having a max crit damage value, which is insane to me because all of this should be completely mangled. I should not know exactly what this function does. I mean, this is just a getter, but still. So if we want to look at something else, and this is where Ghidra helps a lot because it doesn't show assembly code, it shows decompiled code. So there's a lot of other interesting methods within this player attributes namespace. So calculate mana gain for defender. I had to go through this and like think about it. Mana is like the power gain. I don't know why it's labeled mana in here, but that's just what they call it. If using an R4 beast, it's 4K. Yeah. So, but still, whatever the maximum value is, crit damage, just come here, say 4K, and boom, done. Every champ has 4K crit damage. Or if you want to do above that, say 12K crit damage. Technically, you're only restricted by the data type. And the data type for this is a float data type, which is, Jesus, I'd have to look this up because I don't know off the top of my head. Float data type max value. This big ass number is what you could input in there. Essentially meaning you crit huge numbers, which is where you're seeing in Battlegrounds where they gain those like 200,000 hits with one combo or whatever. Anyway, so back to what I was saying before. So there's a method in here called add damage reduction flat. So we can take a pretty good guess at what that does. It adds a flat damage reduction. Again, this is something that blows my mind why these names aren't mangled at all. Because you're able to just go in here, get the offset, go into exactly what I just said, adjust the code, put it back into the APK. We'll cover that in part 2, is how to repack this. Put it back into the APK, and then just sideload it, and you're done. And suddenly you have a modified maximum crit damage value. And we'll do the same thing with, say, let's find another interesting function. This is supposed to be live, so I haven't looked through absolutely everything. So let's come here and say, oh, hey, block damage. So this inputs a base damage value, your opponent's challenge rating, your opponent's block penetration, and then there's some sort of block penetration modification. And then the output is not 0. This is just a generic value. The output is the float value for block damage. So let's say we wanted to adjust our block damage value. And I'd have to debug this, whether it's defender block damage or attacker block damage. I don't know off the top of my head right now. But either way, it still gives you an idea of what's happening. So we're going to copy this offset. We're going to go right back here into the actual code. And would you look at that? We found our block damage player attribute dot block damage code, which you can see takes all the same information in and outputs a final float value. So right here, load register. I need to look at the ARM specification on which register does what, but it'd be pretty easy to find out. I think it's this final XZR X0 instruction. But anyway, so all I would need to do is I could just LOL don't care this entire function. I don't care what the challenge rating is. I don't care what the block penetration value is. I don't care what the block pen mod is. All I need to do is come right here before the end of the method and just put what value I want. It could be 1,000. It could be 0. Whatever I wanted. So this is just kind of gives you a general idea of how people are doing this so easily. Let's do one more. Why not? Maybe we'll do something that's not in the player attributes. See quest boss, quest mass data. I want something that really stands out. And I can see here all the Relics 2 API. Let's take a look through this. Equip relic. That sounds interesting. So in Relics 2 API, equip relic, we're going to have a relic ID, which we don't know what those relic IDs are yet, but we can find them. Hey, yo, Ryman, how's it going? We don't know what the relic ID is yet, but we can find them by debugging, and that's going to be a part 2 video. Rarity ID, I'm not quite certain what the rarity ID means yet. I think that's probably going to be in a dictionary somewhere. String BID, not quite certain what that means yet. But the important bit here is the relic ID and the rarity ID. So let's say we wanted to equip a champion with a certain relic. Well, we'd need to know what the relic ID and the rarity ID is and all the other stuff. But all we need to do is go to this offset right here. So we're going to copy this again. I think you're kind of sensing a theme here. Hey, we got another one. You're kind of sensing a theme here, though. So we're going to go to this function right here. Again, don't care about any of these opcodes, whatever. All we care about is that this in some way equips a relic. So as soon as I can figure out what this relic ID is, then I can then go in and equip my champion with whatever relic I want. So this is just doesn't make sense to me why this is so unprotected in such a high-selling game. So if we want to walk this start to finish, because I want to show you guys exactly how to do this, because I did a lot of this stuff ahead of time, and I want you guys to be able to do this and just be able to browse on your own. I'll be back. Gotta go grind arena. Yeah, we all have more important things to do than disassemble Kabam's code. But actually, before I do that, Kabam, in case you end up watching this, there are some things that you desperately need to do. First of all, let's go find your APK again. APK, com, no, not, I keep clicking com. Why do I keep clicking com? Assets, bin, data, managed, metadata. This file right here, I don't understand why you're leaving it unencrypted, because you're just giving method information and exactly what everything does in the entire file just to the world. This being public, or not being public, because it has to be public in some way, but this being unencrypted kind of blows my mind for such a high ceiling game. Part two, you sort of do it here with your resource files. But once you encrypt your file, these names in here, once I import that metadata file, these names need to be mangled. By mangled names, I mean, this shouldn't say read mail state. This should say A16513, whatever. Like, you shouldn't know what it does just by looking at the method name. And then there's other things that you can do in terms of server callbacks, stuff like that. There's no file integrity checks. You do use SHA-256 checksum, but that's easily repacked by certain tools online. Anyway, all right, I got off topic. Let's do this start to finish, and I'll show you exactly how to do this. All right, step one. We want to download the APK. So, Marvel Contest of Champions APK download. And I got it from APK Pure. So we're going to go here, download APK, and then I already downloaded it, so I'm not going to click download again, but that's how you do that. All right, we have the APK. I'm going to get rid of the unpacked version. Let's get rid of you, delete. All right. Hey, what's up, Thanos? All right, so now that we have the APK here, like we talked about earlier, this is just a zipped file, and so we can unpack it using 7-zip. So we're going to extract files. I went through a lot of this really quickly at the very beginning, but now I wanted to just start to finish with you all. So you can explore this on your own if you want to. All right, so that's unpacked. Now I have all these resources, a lot of these files, property files we don't care about. Based on my explanation earlier, we know that say Blizzard, nothing much, just chilling in bed. I'll be back. Sorry, my chat is messing up. So from what I explained earlier, we know that it is compiled using IL2CPP in the Unity version. And this is the file in question that we care about. So we want to go IL2CPP dumper. We're going to come here. We're going to select code, download zip. I already did that. Downloads. Once that's downloaded, you see IL2CPP dumper master. Let's go ahead and get rid of this one, and I'll unzip it and do it as we go. What was I doing? Oh, press folder tools, extract all. All right. So this is a Visual Studio Solution file. We have no binary for it yet, so we're just going to open it up. I'm using 17, not 19. Yeah, I trust all of your projects because I'm a very trusting person. All right. We don't need to open it. We don't need to go through all the code or anything. We're just going to build it. It's going to give us an error. We don't really care about that error because it only applies to the x86 version. All right, we can close that out now. So now when we go to ILCPP dumper, we have this bin file, debug net64, and we have this command line file that's IL2CPP dumper. Okay, so follow along now. If you're rewatching this video, it's okay, play it back. We're going to go into our Marvel Contest of Champions APK that we just downloaded. We're going to go into ARM64 V8A if you're rocking the 64-bit version, which most of you are. We're going to copy this file, lib2cpp.so. and we'll see we're back in our IL2 CPP dumper debug net 472. We're going to paste this file in. We need to paste one more file in, and that is the metadata file that we talked about. So we're going to model the contest of champions. That metadata file is in assets. Hold on, let me refresh my chat real fast. All right, so that metadata file is in, excuse me, assets, bin, data, managed, there's a lot of folders to go through, metadata, and global metadata.dat. Copy. All right, so we're going to go back to ILSPP dumper master. We're going to that same folder, paste it right in there. Now we're going to open up the command line, command prompt, and I copy this directory, and we're going to cd into that directory. All right, we're in that directory, and if you looked at the GitHub website, it showed you exactly how to run this file, and the way to run this file is to do il to cpp dumper.exe. First, we're going to specify our script object file, which is lib.il to cpp.so, and then our metadata file, which is global metadata.dat. So a lot of things are going to happen right here in the background, and I might explain this in a different video. It's just there's a lot to go into how IL to CPP works, but you can see that it parsed the metadata file. It found all of our names, all of our information for the file, and then it generates this dummy DLL, which we talked about earlier. And that dummy DLL is right here in assembly C#.dll. Pressing the key to exit. All right, cool. We're done on the command line. Next, we're gonna pretend we don't have this. Hold on. I'm gonna delete this. We're going to remove. Okay. So the next thing that we're going to do is we're going to download dnspy or ilspy if you choose to use that one. I like dnspy better. We're going to go to download the release version. On Windows, do the Win64. I don't know why you do the 32-bit version unless you have a super old computer. All right, so that's downloaded. We're going to open dnspy. We're going to File, Open, and we're going to open this assembly C#, not the first pass one, the assembly C# file. Give it a little bit to load. And here we are, assembly C#. And as I was saying, here's all of our method name or namespace information, method names. There's a lot more in this portal executable in our headers that we can talk about in another time. But yeah, so we went over how we can exploit this naming information. So now that we have that, we have our disassembler. It takes too much time to load this entire file, so I'm just gonna show you how to do it. So if you're in IDA, you're gonna go here, script file, and this, if you have Python 2, you're gonna use IDA. If you have Python 3, you're gonna use IDA Py3, or IDA, if you want the structure information, IDA with struct, and that's gonna give you all this labeled information in here. So basically, it's just gonna take all this, the names that you had without code, and it's going to give you Names with code. My code brings all the boys to the yard. Damn right, it's better than yours. Um, so now that we have this code, we can just go to the method name, search for whatever we want, whatever. Let's see if there's anything related to payment. Uh-oh. Payment. Oh boy, there's a lot related to payment. How can we exploit the payment system? Well, we can do it a few ways. I know I looked up a couple different modders files and how they were able to send themselves items through mail. I still don't have a great idea of how they do that, but I'm sure that I'll figure it out eventually. Um, but if you just go through and say payment, let's say, I don't know, is there something called mail item? Oh, there is. Mail item. See, it's a game object though, so that doesn't count. Um, and these are events. But okay, so I just walked you through how to do it. This is the unpacking and code browsing part. Um, I know there's going to be a lot that's over your head. Again, this is aimed at both you guys and Kabam to show how easy this is. There will be a part two. Part two is going to be called repacking and modifying. Now, I don't want to get banned from the game. Kabam, listen to me. I don't want to get banned from the game. This is for your sake. If you want to hire me, cool. I'll show you how you can obfuscate all this stuff and how you can prevent it from being modified in the first place. But my goal here is just educational purposes. I do not plan on modifying my own game. I'm just going to do it just for fun on some side account. But that'll be part two. So I hope you guys learned something, even if a lot of it was over your head. And if there's anything that you can take away from it, know that the reason why modders are so prevalent is because of the lack of security involved in this application. And that's all I want you to take away from it. If nothing else, if this doesn't spark your reverse engineering curiosity, that's what I want you to take away. We need to keep Kabam honest. We need to keep them uh, securing their applications so we as players can enjoy the game better and have more fun. So I think that's going to do it. Part two, again, I don't know when it's going to be, but part two will be modifying and repacking. Hope you guys learned something. Thanks for sticking around. For people that did, um, rewatch it if you want. Try it yourself. All right.